Alright, let's begin. So for this video, we're going to be covering what a button is, as well as the push, check, and held buttons. So the buttons are the main UI component, excluding the sliders. So for here, we have a push button. I click on it, it goes down for a frame, and then releases on the next. We have this held button over here. I did the scale a bit weirdly to showcase that they don't have to be perfect squares. So if I click over here where it should be, if it was a perfect square, nothing happens. But if I were to press on it, it considers push. This is a held button, so while I hold the left mouse down, it will continuously call push because I successfully pushed it on that press frame. When I release, then it calls engine release and updates it. Lastly, we have the check button group, which is a group of check buttons that will be calling things when they are pressed, release, and active based on what you define. So for instance, I have this A button on check, so if I press that, then it releases. I have some screen logs to showcase when the pushing and the releasing occurs, but I also put it over here in the output log to help make it easier to see. The only button that has nothing is this last one down here. This was an intentional thing that I did to showcase that it's the user's responsibility to make sure they define every check button they enter. So the user here submitted 5 check buttons, but if we go over and look at the test check button here, they defined 4. The 5th one they registered was button 7, or that they started updating was button 7. They only submitted entry inside the test canvas up to 5, so that means number 7 never was reached. They have no definition updates for the ID 4. They only have ID 7, but again, they never got up to ID 7, so this does nothing. So it is the user's responsibility to make sure they do that properly. Alright, so buttons. Buttons are composed of an up and down state. These up and down states are what the user can use to indicate what state the button's in, whether it's pushed or released. They have default versions of it. It is something that the user can define as well. However, if the user defines it, it is their responsibility to delete it. So if I were to just quickly go back to the check button over here, you can see that I updated the up and down state specifically for ID 0, and then if I look at the destructor, I deleted them myself. So that is something that the button class itself cannot account for. It is the user's responsibility to keep track of it themselves. Onto the held buttons. So held buttons, they care about check UI press, down, and release. Whenever the button is pressed, we check to see if the mouse needed to be clamped. If the mouse did not need to be clamped, then that means the press was on top of the button. So we set this flag to true. Now on the UI down, we don't care about the mouse position anymore. All we care about is if on that initial press we successfully had a push, so we check that flag. If we did have a successful push, then we call it the engine push, which is where the user can redefine the push functionality. So as you can see here, this is where I have the screen log. That is going to be called once per frame while the engine push is called. This is also where we update the sprite state to be down via the attorney. So this passes all the way through to the button where we update the position of the current graphic object, or we update the down positions graphic object to be at the same position of the current graphic object, as well as updating the scale just in case the user changed that during the gameplay. Then we move the active pointed graphic object to be button down. This graphic object is what is used during the draw 2D step of the engine, so this is used here. Engine release has the button up state call, and that is called whenever we find out that the left mouse has been released and we were already in the button push flag state. So that calls the release stage and also sets the button push state to false. For push buttons use a strategy pattern to help handle the releasing of it. They care about check updates and check presses. So for check press, we do the proper clamping like we did in the held button. If we find out that we did not need a clamp, we call engine push, which then calls the user defined foot push. It will also update the strategy so that it knows to release itself on the next frame. So on the next frame, when they receive the check UI, it will do whatever this action is. There are 2 types of actions: don't release me, which does absolutely nothing because there's nothing to release, or release me, which via an attorney will pass through to the current push button and call the check release, which will call release and then update the action to no release because we just released it. Lastly, we have check buttons. So check buttons are composed of a group of check buttons. So we have all of them starting off in an inactive list. And then once we submit entry, we either do nothing with it, or we can submit entry with specific IDs for the check buttons, and that will start them off immediately in the active state. There are 2 lists. This functions similarly to how we have the inputable setup for the keyboard, where we have an inactive state for the buttons that are not doing anything, and then we have an active state to call the check every frame. So for this, whenever we activate them through the submit entry, this does not call push for each individual check button. If the user wants to do that, they can do that in the step where we connect the UI component to the scene. So when we do the attach canvas call, we can when we do canvas entry, we have the connect to canvas function. This they can just commit where they want to say, hey, I want all these buttons to be considered calling the push. They can do that on their own as a little precautionary measure to make sure that they don't have any unwanted functions being called when they do this entry submission. Setting the active state count. So this determines how many active buttons are shown on screen. We have to make sure there's at least one button and the number of buttons does not exceed our maximum button count, which is 8 over here. So for that, what we end up doing is we move all the active check buttons to a temporary list, push everything into the inactive check button list, and then we loop through our temporary list that we stored. If the index of that button is less than our active count, then we can put it back on the active list to be updated every frame. We get this ID by checking through an attorney to get the ID passed through all the way to here. So for engine push, engine active, and engine release, all three of these are called via an attorney in the check button group. The main difference is that active doesn't change the state of the button. Engine push calls the button down state, and engine release calls the button up state. So that is how we can submit through entry and resizing the count. Setting this down, up, and updating the text all involve getting the current ID and then setting the sprite to be that, typecasting it to an int so that we can find the right index for the check array. During the check UI update, we loop through all of our active check buttons and call the associated check based on the active ID. So once again, we just grab this via the attorney, and then we call the proper check function. For drawing 2D, we loop through all of the active check buttons, and we have it so that they are all rendered vertically, so we decrement the Y offset each time, and then we call render via the attorney to render the check button. Lastly, we have check UI press. So for UI press, we will loop through all of the buttons in the active list, check to see if we ever have a successful mouse click on it. If we do have a successful mouse click, then we will set the button trigger flag to true. Move that button from the active to the inactive, setting and getting the iterator via the attorney again. And then based on the index grabbed from the release call over here, we call the proper release function. If we found a successful push, we can skip this step because this button flag will be considered true. If we did not find a push, then we have to do the same clamping check again. And then if we do find a push here, we're looking in the inactive list. So now we move from the inactive to the active and then call the proper push button here. Submitting exit, we move from canvas and deregister, and deletion is deleting everything in the array. And that's it.